Ocean thermal energy conversion (OTEC) was conceived of by the French engineer Jacques D'Arsonval in 1881. However, at the time of this writing, the Natural Energy Laboratory of Hawaii is home to the only operating experimental OTEC plant on the face of the Earth. OTEC is a potential alternative energy source that needs to be funded and explored much more than it presently is. The great hurdle to get over with OTEC implementation on a wide and practically useful level is cost. It is difficult to get the costs down to a reasonable level because of the processes presently utilized to drive OTEC. Ocean thermal energy would be very clean burning and not add pollutants into the air. However, as it presently would need to be set up with our current technologies, OTEC plants would have the capacity for disrupting and perhaps damaging the local environment. There are three kinds of OTEC. Closed-cycle OTEC uses a low boiling point liquid such as, for example, propane to act as an intermediate fluid. The OTEC plant pumps the warm seawater into the reaction chamber and boils the intermediate fluid. This results in the intermediate fluid's vapor pushing the turbine of the engine, which thus generates electricity. The vapor is then cooled down by putting in cold seawater. Open cycle OTEC is not that different from closed cycling, except in the open cycle there is no intermediate fluid. The seawater itself is the driver of the turbine engine in this OTEC format. Warm seawater found on the surface of the ocean is turned into a low-pressure vapor under the constraint of a vacuum. The low-pressure vapor is released in a focused area and it has the power to drive the turbine. To cool down the vapor and create desalinated water for human consumption, the deeper ocean's cold waters are added to the vapor after it has generated sufficient electricity. Hybrid cycle OTEC is really just a theory for the time being. It seeks to describe the way that we could make maximum usage of the thermal energy of the ocean's waters. There are actually two sub-theories to the theory of hybrid cycling. The first involves using a closed cycling to generate electricity. This electricity is in turn used to create the vacuum environment needed for open cycling. The second component is the integration of two open cyclings such that twice the amount of desalinated, potable water is created that with just one open cycle. In addition to being used for producing electricity, a closed-cycle OTEC plant can be utilized for treating chemicals. OTEC plants, both open cycling and closed cycling kinds, are also able to be utilized for pumping up cold deep sea water which can then be used for refrigeration and air conditioning. Furthermore, during the moderation period when the seawater is surrounding the plant, the enclosure can be used for mariculture and aquaculture projects such as fish farming. There is clearly quite an array of products and services that we could derive from this alternative energy source.